For this video, we're going to take a look at the unit circle and using that unit circle to solve trigonometric relationships. So hopefully you've had a little bit of practice in terms of just developing the unit circle, and there that is as a reference. Okay, now let's take a look at an example where we need to use this as a tool to solve a trigonometric ratio. Okay, so our goal here is to use the unit circle to find the exact value of each trigonometric function. Let's just do in blue, part A. Okay, so what I want to look for is cosine of 225. And just for good practice, I'm going to give myself the good old-fashioned SOH, CAH, TOA. Okay, now cosine of 225, I'm going to have to go, let's see here, this is the first 90 degrees. Here's the next 90 degrees, so there's 180. And then I crank in until I get to 225, which is right about there. Okay, so that means I've cranked all the way around, and what I'm looking for is a triangle that I can base this off of. This is my hypotenuse, and then I'm just going to shoot a line straight up from here that runs perpendicular into the x-axis. This is the triangle that I'm going to use. In fact, let me highlight this because this is the keeper right in here. Okay, so what we're working on now is from this triangle, we can use the coordinates that we have, these coordinates right there on that point. We can use those to help us deduce cosine of 225. All right, so let's pull this triangle out of the coordinate triangle, or out of the coordinate circle. So there's one side, there's another side. Look at how straight those lines are. And there's a third side. And we know that in the x direction, one length is negative root 2 over 2. There's my angle. Here's my hypotenuse, which is 1. And then the other length, the y direction, is also going to be root 2 over 2. Okay? When I'm using cosine, I'm going to use adjacent over hypotenuse. So here's my adjacent angle over hypotenuse. And so my cosine of 225 degrees is going to equal root 2 over 2 all over 1, which just, oops, there's a negative sign in there, which just equals negative root 2 over 2. All right, let's take a look at part B. We'll do this one in black. Okay, so this is tangent of 5/6 pi. Okay, let's come back in here. I'm going to erase these arrows here. And we're going to do tangent of 5/6 pi. Let's do our direction in red so we can really see this. Okay, I know that 1 full pi is 180 degrees, and so that means that I'm going to go right about to here, okay, and then let's pull a line from there straight through 5/6. Okay, and then we're also going to drop a line straight down until we hit that x-axis, because remember, we're always building a triangle in relationship to the x-axis. Okay, and so from here, let's build out this triangle that we're going to use. The new triangle that I'm going to use is going to be about like this. So there's my vertical, here's the side, and then here's the bottom. And I know that for sure the hypotenuse is equal to 1. Okay, and then I also know, based off of this x right here, that the x direction is going to be negative root 3 over 2, and that the vertical distance is going to be 1/2. Okay, we're building off of this angle right here, and the tangent is going to be opposite over adjacent. Okay, and so this is going to be 1/2 divided by negative root 3 over 2. Now, another way that we can write this, if I wanted to get rid of this denominator, is I could multiply by the reciprocal. Okay, so I'm going to multiply by 2 over negative root 3. And if I multiply by that on the denominator, I also have to do it on the top. So 2 over negative root 3. And the cool thing is that these now cancel out and these cancel out. So I'm left with only, in the numerator, 1/2 times 2 over negative root 3. Well, we can simplify that down, right? That gives us 2 over 2 negative root 3. Okay, well, shoot. So what we probably want to do is get rid of this radical sign. We need to rationalize that. So I'm going to do 2 times, and then I have, let's rewrite this, 2 over negative 2 root 3. To rationalize this, I'm going to be timesing it by radical 3, and then in the numerator by radical 3 as well, and I end up with 2 root 3 all over negative 6, which equals, I'm going to reduce this fraction right here, and that gives me negative root 3 over 3.